Hey, ladies and gentlemen, this is Miss Humbert, and I'm going to be doing Unit 9 Notes 4 for you multiplying rational expressions. So today our lesson objectives are simplifying rational expressions and multiplying rational expressions. So we're going to take what we did yesterday and we're going to apply it to multiplying rational expressions today. Now, if you really look at what you're doing today, you have all the tools in your toolbox to handle what we're doing. We're just taking a lot of pieces and putting them together. So a lot of what we did on yesterday's notes are going to apply to today. So let's start by taking a look at, a word problem that kind of represents why we're getting into this stuff. So first, let's take a look at this first word problem. There are 25 lights around a patio. Each light is 40 watts. The cost of electricity is 15 cents per kilowatt per hour. Write an expression to calculate the cost of using the light for 3 hours. So we need to do some stuff with dimensions. Dimensions helps us kind of change our labels to get our answer what we want. A lot of times we look at miles per hour. Well, there's ways we could convert it to miles per minute or miles per kilometer per hour. There's ways we can transform to be the label we want. So let's start off with the fact that we have 25 lights. So we have 25 lights. So I'm going to write that down first. The next thing I learned is that each light is 40 watts. Okay, that's my next important stuff. Again, I'm really focusing in on those labels. So what that tells me is there's 40 watts for each light. So for every one light I have, there's 40 watts. So I'm setting up a proportion for each of those. And setting up those proportions is going to help me change my label. The next thing I know is that for every 1 kilowatt, it is going to be 1,000 kilowatts. Well, how did I get that? Okay, well, let's look at this. Kilo means 1,000. So that means kilowatt is 1,000 watts. So this right here that I just did was to help me change my label. Okay, so I noticed that later it tells us that it's 15 cents per kilowatt. So I don't want to know how many watts there are. I want to know how many kilowatts there are. So that's why I'm dividing everything by 1,000. The next thing I'm going to do is take what I actually know about the money, 15 cents per kilowatt. That per a lot of times tells you that you're going to be setting up a proportion. So I have 15 cents per 1 kilowatt. And eventually the problem is going to ask us to write an expression to calculate the cost of using 3 hours. Well, now, because I'm to cents, I've calculated up to the cost. So now I just need to figure out how much it's going to cost per hour. So that's for 3 hours. So really, since I've gone through and changed all the labels, now all I have to do is calculate those numbers, multiply them all together, and make sure that my label is actually canceling out. So lights cancels out with lights. Watts cancels out with kilowatts, and here, or watts, sorry, and kilowatts cancels out there. So now all I have to do is take 25 times 40, divide that by 1,000, and then multiply it by 15 cents times 3 hours. So when I do that, I get 45 cents for those 3 hours. Okay, so it's going to cost me 45 cents for the 3 hours. Okay, so let's take a look at what this multiplying expressions is kind of getting us towards, okay? So remember, go ahead and pause the video if you need to, because I'm going to talk faster than you can write. I also might talk faster than you can understand. Just because I'm doing an actual problem doesn't mean you need to pause the video, or doesn't mean you can't pause the video to look at the problem that I'm doing. So here are our steps for multiplying rational expressions. First thing we want to do is multiply the numerators. Okay, so we're going to multiply the two numerators together. We know how to do this, whether it be multiplying binomials or multiplying monomials. Okay, next is to multiply the denominators. That's going to follow the same step as step 1. Next, we're going to simplify the fraction that remains. So we're going to do a lot of what we did yesterday. That third step is really just pulling together what we did yesterday. So let's go ahead and take a look at this. Okay, so first thing we want to do is multiply. So we want to multiply those numerators together. So the first thing I'm going to do is multiply coefficients. When you're multiplying monomials, you multiply coefficients, add exponents. So I'm going to take 5 times 16, and that's going to give me 80. Okay, so now I'm going to continue multiplying across. Well, I see the first monomial has an a, but the second one doesn't. So I'm going to keep that as a. Remember, that's the same as a to the first, but we don't have to write a to the first. We just know it's there. Next, my next letter is b to the third. Well, I noticed in that second monomial in the numerator, there is no any b's, so I'm going to keep that as b to the third. Next, again, c to the third doesn't have anything to be multiplied with, so it's going to stay just like that. Okay, so now I've done step one. I've simplified my numerator. All I did was multiply them together, just like you did on notes 2. So next, let's take a look at the bottom. First thing I'm going to do is multiply coefficients. Remember, you're multiplying coefficients and adding exponents. Okay, so a squared doesn't have anything to be multiplied by, neither does b, and neither does c. Okay, so really once we've got to this point, this is exactly like yesterday. So first thing I want to do is try and reduce that 80 over 120 fraction. Okay, and I can actually reduce that fraction to be 2/3. Okay, so now I have a over a squared. So I'm just going to do a little work up here. So if I have a to the first minus a squared, that's going to give me a to the -1. Well, a to the -1 is going to be negative on top. So I know I'm going to have a to the 1 on the bottom down here. Okay, so now I'm just kind of going through and reducing as I go. Next, I'm going to focus in on my b's. So now I have b to the third minus b to the first. Remember, when you divide things of like bases, you subtract the exponents. This is just like you did on notes 2. Subtracting the exponents, you're going to get b squared. So then on the top of this fraction, I'm going to have b squared. Last but not least, on my c's, I have c to the third minus c squared. Subtract those exponents and you get c to the first. So I'm going to write that on top. So I have 2b squared c over 3a. All right, let's take a look at number 2. So again, multiply coefficients, add exponents. Well, there's no coefficient here, so that coefficient is just 1. So 5 times 1 is 5. So now I just want to go through and combine my letters in the numerator. And I like to do that mainly by just going in alphabetical order. So that way I make sure I keep track of everything. So c cubed times c to the first, add those exponents and you get c to the fourth. D to the first times d to the third, add those exponents, you get d to the fourth. F squared is just by itself. On the bottom, I'm going to pull that 10 out front. Now I'm going to combine my c's. C to the fourth times c to the first is going to give me c to the fifth. And then I just have d, and then I have f to the fourth. So now I want to go through and simplify this rational expression, okay? So again, this is exactly like you did in notes 3. Step 3 is the same as notes 3. 5 divided by 10 can be reduced to 1/2. So now let's take a look at these. First, I'm looking at c to the fourth divided by c to the fifth. Well, when I subtract those exponents, I get c to the -1. If you notice, the bigger number is on the bottom, so that's where my c's are going to end up. 4 minus 5 is 1, so I'm going to have c to the first on the bottom. With d's, if you notice, my bigger exponent is on top, so my d's are going to end up on top. D to the fourth divided by d to the first, subtract those exponents, and I'm going to get d to the third up here. Last but not least, f squared divided by f to the fourth. Divide out those exponents, or dividing those expressions, you're going to subtract the exponents. 2 minus 4 is -2. The bigger number is on the bottom, so I'm going to keep my f2 on the bottom. So again, if you're getting tripped up on that step specifically, go back and review notes 2 and notes 3, okay, because that's where you get your rules of exponents. That's where you get your simplifying rational expressions. Okay, let's take a look at the next 2. What I'm going to do is I'm going to get number 3 started for you, then I'm going to have you finish it, and then I want you to try number 4. Okay, so let's take a look. First, we have 16 times 3. Okay, so when we do that, we have 16 times 3, and we're multiplying out those exponents. Okay, so that's going to give us 48, or sorry, multiplying those coefficients. So then g squared times g squared, add those exponents, and you get g to the fourth. H to the third times h to the first, that's going to give us h to the fourth. Next, 8 times 3 is, 8 times 32. Multiply those coefficients and you get 256. Okay, g, nothing to multiply it by, so I'm going to keep g to the first by itself. Then h squared, this is going to be h to the first, so that's h to the third. And then j squared. So now I've gone through and I've done steps 1 and 2. I've multiplied the numerator and the denominator. I want you to go through and simplify that now. Okay, and then I want you to go ahead and try number 4 on your own. See if you can do that. Remember, you're going to multiply coefficients and you're going to add exponents of only things with the like bases. Make sure they're like bases. So I want you to have a great night, and do make sure you remember to take that Schoology quiz once you're done.